Is that me? Don't do that. That would be in that one. Just start? I'm good to go? Okay. We'll get started. So my name's Tim Wilson. I'm with Search Discovery. Welcome to day 2 of Superweek. I joined Search Discovery at the beginning of this. I somehow thought that I was not going to get away with such an easy start. Superweek! Superweek! Are you going uncomfortably long or no? No. Day 2 of Superweek. So I'm going to start before I actually dive into the actual topic. So I work for Search Discovery, started there in early January, largely because they are very aligned with what I think is the future of analytics, of which there was a lot of discussion yesterday. So we're going to talk about the path from Excel to IBM Watson. I'm not actually talking about IBM Watson. It's more the idea of artificial intelligence and machine learning is what we're going to talk about. Getting from where certainly I came from, which was being a power user of Excel with web analytics, and what does that path look like? A lot of the questions during yesterday's panel, I was sort of hearing the subtext of people saying, I get that you guys are talking about all this exciting and interesting stuff, but how in the hell do I actually move in that direction? There's this huge chasm as to how do we get from our world of traditional web analytics into that world. So that's what I'm going to try to talk about, and hopefully there were questions yesterday saying, where do I start? And that was being asked of a panel of experts who were there. And they're saying, how do I sort of back into it? Whereas I'm going to come at it from, when we're in the world of Excel, what's sort of the steps we can take in that direction? Not going to totally have you doing AI by the end of this session by any stretch of the matter. So Victor, I found out, left this morning. So I did tell him that his headshot was here. But during his session, he made a comment. He said, if you're not diving into machine learning yet, now is the time to actually start. And when he said that, I was like, oh, crap, I'm not yet diving into machine learning, but I totally agree with what he's saying. So hopefully this is a nice build on the non-GDPR aspects of yesterday. So we'll start with a little tale. Once upon a time, there was an analyst. That analyst was me. He had a deep and abiding relationship with Microsoft Excel. He had known her and loved her for years, was a power user, was very, very comfortable in the relationship, but hit a point and started to ask, is that kind of the rest of my career? Am I just following this Excel path? There were a lot of people starting to talk about Tableau, people that I knew and respected who had said, wow, I switched to Tableau and I'm never going back to Excel. And I was like, ooh, should I follow that path? There were people saying, I'm using R, I'm using Python. And I was thinking, ooh, that's not on my path. Should I follow that path? And it turns out we've got a ton of choices of which sort of path to follow kind of beyond Microsoft Excel. I think that it really boils down to 2 paths. And we're not picking one or the other. There's absolutely no right path and wrong path. Actually, most companies probably need to follow both paths. And that path starts with Excel, or maybe Google Sheets. That's really, let's just say spreadsheets, because Google Sheets continues to progress and close any sort of gaps it had with Excel. And one path is the path to, I would say, a overall path to like Tableau or Domo or Data Studio. That's the path that has, hey, we've got to be getting broader data sets available to our users in one spot. We can't be exporting from our CRM and exporting from analytics and putting them on a sheet in different worksheets and emailing a file around. We need to have some centralized mechanism, regardless of where the data is stored or how we're doing it, where our users can access one piece of data or one more integrated view of the data. Absolutely. It's also, we have to be able to do richer and more interactive visualizations. We need to enable users to slice and drill and filter on the data, also super powerful. Ultimately, that's getting to this ideal of data democratization. Let's get more data safely into the hands of a broader set of users, and there's an enormous amount of value in that, and that's the last I'm going to talk about that path. The other path is kind of interesting in that it starts really with the destination. Is we say this other idea, and again, a ton of discussion yesterday about it, is we want to get to that destination of artificial intelligence. But it's really hard to make that leap from Microsoft Excel and a spreadsheet to AI. So in that case, I sort of work backwards from AI. to get to AI, right, Jim's whole talk, his book, Practical Applications of Artificial Intelligence, but we wound up on the panel yesterday, it was machine learning. Because it turns out we really sort of need to fully grok and grasp machine learning if we really want to do stuff with AI. And I would say to do machine learning effectively, we actually have to think differently. We have to start incorporating statistical thinking, which is this kind of vague idea, but I think it's really important. And one way to start thinking statistically is to actually start applying real statistics to the data that we're working with. And I will claim that over time, the more that we start to do that, we will find that we are thinking differently about the data, and it will be a much more natural flow into machine learning. So the second path, I think the first step along that is to actually dive into statistics with the data that we've historically worked with in web analytics. We have to think differently about the data. This is a picture, and before Victor left this morning, he confirmed that he'd seen this. Russia had a project last year where they took a bunch of plywood panels and they gave them to a ton of kids who were 4 to 10 years old, and they said, paint your idea of a rainbow on this plywood panel. And then in Gorky Park, they set up this long fence and they put all those panels up along it. It's kind of a neat installation. And so you see a lot of rainbows, but then you see there was, some kid was like, I love to paint, and rainbows are okay, but I love crocodiles. So I'll give you your damn rainbow, but then I'm going to draw a crocodile. And somebody else was like, I see that you asked about rainbow, but you're really asking about the colors of the rainbow. So some kid said, I'm just going to paint a picture of a person using the colors of the rainbow. And we know that kids are much more able to fundamentally shift the way that they think. They haven't gotten kind of the rigid brain neural processing that we have. But still, most of them just painted a rainbow. Well, I think a lot of us have fallen in the trap with web analytics data, how Google has conditioned us to think about the data, because we started with their web interface, maybe we moved into the reporting API, and we need to actually be thinking crocodiles a little bit more than just rainbows. So I'm going to talk about 3 ways of thinking differently. We're going to dive into 2 very specific examples to do that. One is aggregation. We have been conditioned to think about the data. We're not even aware we're thinking about aggregated data. And it turns out when we're mired in the world of aggregation, if we start reading up about regression models or ANOVA tests or statistical operations, we start talking about variables. And it turns out, and I hit multiple walls doing this. I'm like, I want to use a variable, but what's a variable in Google Analytics? How does a variable translate to dimensions and metrics? Is channel a variable? Because if channel is a variable in my values or paid search, organic search, referral, direct, then I'm actually missing any quantity for those variables. How does that actually work? And I'm sure many of you are like, yeah, you're just not thinking about it right. I'm hoping a few of you are saying, yeah, that is confusing. If I'm not just doing a regression of visits and looking at a correlation of visits and orders, that starts to be a little bit of a challenge. But if we dive into aggregation and deaggregation and detailed data, that becomes very, very clear. Another topic is time series. We're all totally used to working with time series data. We accept it, we've internalized it, we're trending stuff all the time. We know our data is time series based. But it turns out in the world of statistics, time series is kind of an advanced topic. I actually, on a hunch, went and started looking up degree programs, university programs for getting degrees in statistics, and there would always be a class on time series, an entire class devoted to it, and it was never in the first semester or the second semester. It was an advanced topic. Yet all of our data is time series. When you look, if you read books or blogs about applying statistics for marketing, 90% of the time, just made the 90% up, the majority percent of the time, lack of precision there, they're looking at market research data, which is not time series data. They've got survey data and saying, how do you actually perform operations? Yet our web analytics data is inherently time series, and that actually introduces some challenges and opportunities. And really those kind of build to a topic, an idea that is core to statistical thinking, which is uncertainty. And uncertainty is this weird idea, the Deming quote of, in God we trust, all others bring data. I feel like we bastardized that. There's a poster somewhere around here talking about opinions versus data. And I think we overinterpret data. We see data as being facts, which they are, and then we think that because we have the facts that we have the truth. And the fact is we never have the truth. There is no truth. And we need to acknowledge the uncertainty that we're working with and figure out how to work within that. So we'll build to that. That's a little bit more of a amorphous topic, but hopefully the light bulb will go on by the time we're done. So let's talk about aggregation. We will start with an example. In both of the examples I'm going to talk through, we'll start with something that is like stupidly simple, like day one, this is Google Analytics aggregation. And hopefully about halfway through it, we'll take a little bit of a turn, and you'll be like, oh, that's kind of interesting. If you're already doing a bunch of machine learning, none of this is going to be a surprise to you, but maybe there are some approaches you can steal here to communicate with people who have not made it to the plane that you're operating on yet. So what's the most aggregated question we can ask? How much traffic came to our site last month? It's definitely an aggregated question. The data set I'm going to use was 2.5 million sessions last month. We never just look at that one number. We would say we want to understand that a little bit more. Hey, let's look at that data by day. It's a 30-day month, so it's a fairly stable month. There aren't any like huge spikes going way up. So that's one way we break it down. So instead of one aggregated number, we have 30 data points. Another super common way that we'll look at it is the default channel grouping report in Google Analytics. Let's break that down by channel. So, okay, that's pretty useful as well. We can now get a sense of where the traffic's coming from. So here's where things start to get a little bit interesting. If I asked how many rows of data went into that table, I know that if I was going to build this table using Excel and the Google Analytics web interface, I would go to the default channel grouping report, I would export it, it would generate a table of 7 numbers, and that's what I would plot. And that's the way I would have thought about it. I have no idea the thousands of bar charts I've built like this, and yes, it seems like there are 7 rows of data. But if we asked a data scientist, how many rows of data went into that chart? I think most data scientists would say, well, really 2.5 million rows went in. It's definitely hard to see in our backlit, but that's a table where each row is a visit ID, and then in the column is the channel. So the first one says social, the second one says display, the next one says direct. It's 2.5 million rows of data that have just been aggregated into a representation that is a 7-bar bar chart. That's a fundamentally different way to think about the data. So data scientists will do kind of something interesting often, is they will say, if that's what my data table looks like, 2.5 million rows, and now my variable is channel, and there are 7 levels, 7 possible values for that, social, display, direct, paid search, etc. Sometimes we don't want to work with that kind of data. That's a nominal variable or a categorical variable. So they'll do a transformation and use dummy variables. And they'll say, instead of one value, we're going to transform the data. We're not going to add or remove any data. We're just going to represent it differently. And we are going to make a table that has 7 columns, 1 for each channel. And then we're going to code each value as a 0 or a 1. So now my first row on the left says visit ID 56 something something. Channel is social. On the right, it says same visit ID, and then it's got a referral heading that's 0, an email one that's 0. You get all the way over to social, and it's got a 1. It's representing the exact same type of information, not adding or removing anything. It's actually redundant. I can take any one of those values and remove it, and I'll actually need to do that for some types of statistical operations. In this case, the last column is paid search. I'm going to take that away, and it turns out I haven't lost any information. Because now, if I hit the 4th row is paid search on the left, the 4th row on the right has the same ID, and it's got zeros for all 6 columns, which then makes me realize that it must be the column I deleted, that's paid search. Either way works fine. Depending on the statistical operation we're doing, we may use one versus the other. But I built to that to say now we're actually getting to where we have statistical terminology that starts to make sense when we're reading the vast number of resources that talk about how to do regression models and ANOVA tests and other things. Each row is now an observation, right? We don't really have observations when we're looking in the web interface. When we have multiple observations, we have a sample. And we've kind of been conditioned to think sampling is bad, but when you've got 2.5 million rows of data, you have a severe risk of overfitting and finding statistical significance where maybe you shouldn't, because that's almost too much data. So when we think about this as being 2.5 million rows of data, now we can say, oh, we can pull a sample, and we can use that sample of the data, 10,000 rows, to train a model, and then we can pull another sample of 10,000 to test the model. So now we're kind of in the world of statistics speak, and we've just done some kind of light modifications in the way that we're thinking about the data that we're used to working with. And now we do have a variable, and the variable works with either the other representation or this one, but in this case we have a variable that is the direct channel, and it's a variable with two levels. It's got a 0 or a 1. A 1 means yes, a 0 means no. So cool, like we've gotten into a world where now we're actually using statistics speak, and that's a good thing. So I took a little bit of a turn there and said, oh yeah, you just have to, instead of getting 7 rows, you have to get 2.5 million rows. Well, how do we do that? Well, there are lots of options, and there are lots of ways that we're progressing in that direction. Anytime that if we're just using a plain vanilla Google Analytics implementation and pulling data through the web interface or through the API, we're working with aggregated data. Anytime that we're relying on dimensions and metrics together to give us information, that is definitionally aggregated data. But we don't have to use aggregated data. We can spend money with Google and say we're going to go with GA360. That is what BigQuery is detailed data, session-level data, just like the table that I represented earlier, but with way, way more columns. So that's one way to go. Simo, who 2 years in a row, ever since I started coming to Superweek, Simo stopped coming to Superweek, had a kid, needs to spend more time with the family, but he winds up here in spirit anyway. His picture's on the wall, he makes it into presentations. Well, he wrote a post back in 2015. There he is. Look at that, he's here. So he wrote a post in 2015, improved data with 4 custom dimensions. One of those custom dimensions is just generating a visit ID. Kind of clever. He's like, send a random number with every hit to a session scoped custom dimension, and really just the last one that you sent is going to be your random session ID. And I am not a heavy GTM user, I'm not a heavy technical guy, and it took me like an hour to turn that on, enable that for the analyticshour.io for our podcast website, and yeah, now I'm pulling data out that is completely detailed data. Obviously that means we don't get a ton of traffic to analyticshour.io, it works fine. I still have to pull with a metric, and that last column is sessions, but sessions is always going to be 1 because I'm working with observation level data. So once you get to the point where your metric is just always going to be 1, you've kind of definitionally gotten to a detailed view of the data. So that's an option. Mark Edmondson, interestingly, like Simo, wanted to spend more time with his family, but rather than not coming to Superweek, he just brought Rose and Santa with him. So similar challenge, similarly brilliant guy. Another solution to that underlying problem. So analysts, they're clever. We come up with different solutions. He wrote a post back in 2012. It's all about, like the title is real-time forecasting with Shiny, a whole bunch of like really cool stuff. And the fact is the first step that you need to take in that post is, hey, why don't you just take using GTM and Google App Engine and just take the raw hit that's getting sent to Google and just send that straight into BigQuery. So now you're building a table with hit level data. It's not been filtered, there's been no sessionization, so it's raw data, and it does take some technical chops to do it, but that's another option to get detailed data. Last week, so we've had Simo Ahava, we've had Mark Edmondson, now we have Karnak the Great, Johnny Carson. Snowplow had a release. Are there Snowplower users here? Show of hands, there are a few. So this is Karnak for those of us of a certain age. That had nothing to do, they named their release Karnak, it was a totally different Karnak, but sticking with the theme, but they're now making it easier and easier to use the measurement protocol to push raw GA data into the Snowplow environment, which gives you that detailed data. So there are lots and lots of options, and I think we're all going to start realizing that we've got to be following something like that because that's the data that's going to put us on the path to that more advanced use of the data. So what if we haven't done any of that? Should we abandon all hope? Is there nothing we can do? Well, we want to move towards that ideal, but that doesn't have to be the first step. Sort of hope springs eternal. I've got a dog that thinks she is someday going to catch a bird, but that is not going to happen. We don't have to go to that level of detail. We can do just some de-aggregation and start to develop some intuition about the data and thinking about the data differently without actually going quite that far. Now, we do have to take a couple shortcuts. It is a little bit risky. We have to cheat a little bit. We have to be careful. But for the sake of this exercise, I think we're going to be okay. So we're going to ask a slightly different question about that aggregated data. And the question we're going to ask is, does channel really impact the number of sessions? And again, I'm using sessions. It could be any metric. And it turns out that's an interesting question. I can eyeball this and say there's kind of a fairly steady stair step down. It does really kind of look like each channel is driving a different number of sessions. I can eyeball it, and I'll be right. And the punchline for this example is yes, channel, shocker, impacts the traffic volume. But we're going to dig into it to try to get some intuition about how, in cases where it's not quite that clear, how we might use a similar approach and get a better answer to that question, or a more defined, objective, quantitative, quantified answer, which is what we need if we're starting to expect the machines to look at things and make decisions. So we had our 7 data points. Now we're breaking it down and saying, instead of, we looked at all traffic trended by day, and we looked at all traffic broken down by channel. If we do both of those, we get a really messy line chart. But we can start looking at it and saying, yeah, paid search is that top line. It looks like it generally is driving more traffic. Organic search is the next one. It generally is driving more traffic. But then we get to like the one with the spike, that's social media. And there were some days where social actually drove more traffic even than paid search. So we can start to see that it does look like channel, that traffic volume does differ by channel. But it gets a little murkier when we start to see there are some channels where things are kind of moving right along with each other, or the lines are actually crossing. So what we've done is we've gone from 7 data points to 210 data points, because we've broken down each channel by day, and that gives us 30 days, 7 channels, 210 data points. So we've deaggregated the data. It's not detail level data, but we've got a little bit more data to work with. So we're going to cheat at this point. We're going to say we have 210 data points, and we're going to use day as kind of a proxy for our observation, which means we're going to, because day, there's not like some steady trend going on here. The spikes just look kind of random. They don't look like they really build on each other. So we'll say, okay, we're going to deaggregate the data by day, and what we're going to do is ignore the time aspect of date. Remember I said time series is kind of complicated? We're just going to pretend time doesn't matter. Although we're not going to care about the fact that the second comes after the first, the third comes after the second, the fourth comes after the third. We're going to say, no, the date is really just an identifier of an observation. And once we do that, this order of a line chart doesn't really matter, but we can actually build a histogram, where now our x-axis is the number of sessions, and of those 210 data points, we're counting how many of those days had between 0 and 5,000 sessions, which was somewhere over 50. How many had between 5,000 and 10,000? So we have a histogram, which a histogram is a distribution. So we're getting to a point of a distribution of observations, which is getting us closer and closer to that world of statistical speak. Histograms, the challenging thing with them is you have to pick the bin width. And there are different strategies for doing that, but a way to avoid having to pick that we wanted to do buckets of 5,000 is we can do instead a density plot. So this is a way that just smooths things out. I've taken the y-axis off because it becomes kind of non-intuitive and really, I think, not that important. But right, if we looked at this with a histogram, this is just a smoothed out representation of the same thing. So we have a distribution. Everybody's taken some statistics and says, yes, but that's not a normal distribution. Do we have a problem? And I'd say, well, nah, hold on, maybe not yet. That's looking at all 210 observations. What if we just took one channel? What if we take just social, use the same 5,000 bins, and just break out those 30 data points? Well, now we're getting to something that when we make a density plot does start to look like a more normal distribution. So it's social. We saw that it had a spike, so there's this little weird thing happening on the end. But generally, we're getting to something that feels a little more statistical friendly. So now we're going to go back to our overall distribution, and I'm going to do some data visualization transformations, which are just needed to kind of get to where we get the larger intuitive impact. So the first thing I'm going to do is I'm going to flip this whole thing horizontally. So I'd like everybody to think in their mind, what's this going to look like when I flip it horizontally? Because I don't want to act like I'm doing any sleight of hand. I flipped it horizontally. Zero's on the right. So I did that because I'm now going to turn the whole thing up and kind of squish it over on the left. So now I have that same funky distribution just represented over on the side. So now I'm going to take each one of those channels, just like I did with social media, and do their distributions. So I'm actually representing the same thing I was representing in that line chart, but hopefully now we're seeing something that looks like, that's interesting. These seem to be centered in different areas. If I added up all of the ones, the 6, the 7 on the right, they would equal that distribution on the left. Obviously, the scale's been kind of changed. I may want to look at the mean of each one of those distributions. Again, we're using this, it's exciting, we're using statistical language. So if I do that and I start looking at these channels and I look at where the means fall that are different, and I look at how much spread, how much variability there is for each channel in the observations, or how much variance there is in the observations, I'm starting to analyze the variability. I'm analyzing the mean and the variance, and I can say it really does look like, for the most part, each channel does really look different. It does look like channels impacts the number of sessions. So an analysis of variance is an ANOVA. It's a one-way ANOVA because there's one variable, which is channel, and I'm doing an analysis of variance on that. This is a visual depiction, but I can actually run the process. You can do this in Excel with the analysis tool pack. You can do it in R. You can do it in Python. Pick your tool, and it will generate text output. And in that text output, there will be a p-value. When R outputs it, it says PR parentheses greater than F. I'm not really sure. I know the F is the F value. It's got a really small number. And we know that really small p-values generally mean like, ooh, we want to see really small p-values. When we see a p-value that's effectively 0, that leads us to this statement of we can reject the null hypothesis. More confusing language for us, except the null hypothesis is always the assumption. Let's start with an assumption, or start with a hypothesis. There's nothing there. So the null hypothesis in this case is that sessions is not really different by channel. That's our base assumption. And when we get a low p-value, we reject the null hypothesis, which means we say, yeah, it looks like sessions do actually appear to differ by channel. Everybody with me? Is anybody thinking this is kind of interesting? We got to some, okay. So the kicker with the ANOVA is that it doesn't tell us which channels are different. It just tells us that, yes, channel impacts the number of sessions, which 100% of this room knew that walking in and would have expected that. But we're trying to get the intuition. It doesn't tell us which channels differ, and we may actually want to know, well, which channels are actually different. And to do that, we do this thing called a Posthoc Test. We get into using fancy words. We're going to do an after-analysis test. And one of them, the one we're going to do, is called a Tukey Posthoc Test. This is John Tukey. He died, I think, in early 2000s. There aren't that many pictures of John Tukey floating around on the internet, but look what's behind his head in this picture. It's a distribution. So the Tukey range test, he developed various things, but the Tukey Posthoc Test says let's compare each one of these levels of the variable on their own and see which ones actually varied. So this is a Tim Wilson visualization of this, I haven't actually seen anywhere, but it's helpful for me. So this is like one of those old road atlas charts that says what's the distance between two places. If we look at any row and any column and where they intersect, that's the p-value for testing the null hypothesis of there's no difference between these two channels. So if I go over on display and down on email, my p-value is 0.0033, which says, yeah, display appears to be different from email. And that's the case with almost all, because we're working with channel, and that's almost always the case. But hey, look, we've got one up there at the top left. We have a pretty high p-value, 0.85, for email and referral. Now, we know that email traffic is definitely different from referral traffic. But we're not really talking about the quality of the traffic or the revenue from the traffic. We're just looking at sessions in isolation. If we take that high p-value and go back into our visual depiction to test that intuition, well, email and referral are these last two. And if we look, their means are not that different. And they both have a very tight distribution, even though email had a couple of email drops. So that actually matches up. That's giving us that post-hoc test saying, yeah, when it comes to the volume of traffic, we're not really comfortable saying that email and referral are driving different volumes of traffic. And looking at this distribution, that matches. The quantitative p-value actually matches our intuition. So why go through all of this when we could just eyeball it in the first place? Well, that's a one-way ANOVA. What if we wanted to look at channel and device category? We can do that with the same idea, but now we're getting into more dimensions, more variables. That would be a two-way ANOVA. It starts to get harder to visualize. We can do up to an n-way ANOVA. We can pick as many variables as we want and do the same thing. If we have the intuition and conceptually understand a one-way ANOVA, then we can start to understand what a p-value for an n-way ANOVA is telling us. So that is why we need to get to that detailed data. We cheated. We went to 210 observations using day instead of getting to the full 2.5 million observations that would be kind of more ideal. But even with that, we started to see these distributions and started to see how we can look at the mean and the variability and start to apply some statistical approaches to it. So, everybody with me still? I'm going to stop beating that example into the ground and say, you know, we threw out the time impact of day. Now we're going to do the exact opposite. We're really going to focus on the actual time, impact of time on our data. So we're going to ask a different question, different data set, again, because we're trying to develop some intuition here. And we're going to say, did that KPI move enough last week for me to care? I went back and looked at the session I did here last year, and I kind of hit this same example, but what I'm going to do here is different, and then I'm really going to, not that anybody remembers what I talked about 30 minutes into a session a year ago, but I know, I care, and I'm about original content. I'm here for you. So we're going to dive into time series and something that Mark Edmondson, who, as I've said, is operating on another plane, yesterday lit up. When I said, I'm going to talk about time series decomposition, he was like, that is so cool. And then he proceeded to rattle off an example from recently with a client where what I'm about to talk to yielded some real, meaningful, and legitimate insight for them. But to me, one of the ways to come at it is asking, did that KPI move enough for me to care? Whenever we have a KPI, we know that it's never going to be exactly the same from week to week or day to day or month to month. But when it moves up or down, how much does it have to move for us to say, that might be a change in the signal, not just due to noise? And it turns out it's hard to kind of objectively make a call on that. So in this case, we can see that last week, the data went down a bit, and we see that, but it's not lower than it was 6 or 7 weeks ago. So should I freak out? Should I dig in farther? Or is this just kind of normal variation? Well, it turns out I can use what's called a Holt-Winters forecasting method, which uses time series decomposition to figure that out. The first thing I'm going to do, there's going to be a theme here, is I'm going to deaggregate that data. Right now, I have 7 data points, 1 for each week. I'm going to turn that into 49 data points. Oh. And now I've got the familiar weekly humps. Show of hands, how many people's main website, when you log into Google Analytics, has the weekly hump with the dips on the weekend, right? Pretty common. So, which is why we try to not look at it this way, because it confuses people. They're like, dips on the weekends. Let's just aggregate it by week. Well, it's actually really useful to drop it back to the more granular level. So now we've got 49 data points, but I'm going to split those up, because last week, which was 1 data point, is now 7 data points. And that's going to be our data of interest. Did that move enough for us to care? Which means the previous 6 weeks, 42 data points, that's our data for context, or our training data. Maybe we're going to build a little model, and we need to train our model using that prior data. So what we're going to do is we're going to decompose our training data. We're not going to throw it out in the yard and let it rot and sink into the ground. We're going to break it down into component parts. So we've got our actual data. The first thing we're going to do is, the most obvious thing we see is that recurring pattern. That's a 7-day season. That is seasonality, not operating on an annual basis, operating on a weekly basis. So the first thing I'm going to do is say, what values can I get that exactly recur every 7 days that explain as much of that data as possible? So those two look kind of similar. The bottom one, the seasonality, it is the exact same value for every Monday. It's a different value for Tuesday, but the exact same value for every Tuesday. We're going to explain as much of that as we can and figure out what pattern that is. Excuse me. Then we're going to subtract that out. And we're going to take what's left, and we're going to do basically a moving average. It's technically exponential smoothing. But after we've subtracted that out, we can take what's left, and we can make kind of this smooth trended line. How is the data trending after we've removed the seasonal, the 7-day season. Then we take those two values, subtract them out, and what's left is our noise. So we've decomposed our time series into 3 component parts. And they all look very different. And again, they have different Y scales, or you wouldn't be able to really see the magnitudes differ enough that you kind of have to let them just sort of float freely. So now I can take the top 2 values, or the seasonal and the trend, and I can forecast by day for the next week what I expect to happen. Forecasting the seasonal component is really easy. I just repeat the same pattern of 7 values for another week. The trend, it's basically extending the trend, kind of a little bit like we'd classically fit a trend fit line. And then I add those together. So that seasonal and trend component, I add those together and I get a forecast by day for Sunday through the following Saturday. But I know that the forecast won't be perfect, because forecasts never are. So how close do I expect my forecast to be from reality? Well, that's where I use the random component. Because my noise component, maybe the noise component went like this. There's not a whole lot of variability. There's not a whole lot of noise. Or maybe it went like this. It's a super, super noisy signal. Either way, the more magnitude there is in that noise, the broader I need to, the less likely I expect my actual result to really match exactly my forecast value. So I take that random component and I use it to generate a prediction interval, which is really hard to see. But there's a gray band around that centered section. That's my 95% prediction interval. In the absence of a change in the underlying facts of the world, 95% of the time, I expect my actual results to fall plus or minus some amount from my forecasted value. So I'm starting to get kind of objective. So now I can go back and put my actual values back on, and it gives me some good context. And in this case, actually tells me that 4 of the last 5 weekdays last week, I was below my 95% prediction interval. I expect to be outside my prediction interval 5% of the time. 4 out of 5 weekdays, that seems like a lot. So in this case, I would say, yeah, something looks like it did change that was meaningful. So, quick check. Somebody raise their hand and say, that's pretty cool. Anybody feel like that was kind of cool? Like,
that's pretty cool.
Outstanding. I'll give you the $20 later. So, we did that with one metric for all traffic. And that's a very simple, that is a Holt Winters forecast, and you throw that into one of your tools, it can do that exercise. That was all traffic for a single metric. The way that I have used it regularly is, I don't really want to look at all traffic. I know that I want to break stuff down by segments. I want to look at it by channel. I want to look at it by device category. I want to find anomalies in the data at a more granular level. And I'm probably not just looking at sessions. I may look at revenue, and I want to look at orders. I may want to look at multiple other metrics. If I multiply those together, all of a sudden I'm repeating this exercise for a whole lot of different things. And most of them are going to come back and say, yep, we're within the band, the range of what we would expect. But we'll have a couple that maybe pop out and say, wow, this combination, things were higher or lower than were likely just explainable due to noise. And voila, we've done anomaly detection. This is actually how Adobe Analytics does their anomaly detection, is using that basic approach, the Holt Winters forecasting method, comparing to the prediction interval your actual values. So that's kind of useful, and we had to deaggregate the data to do that. So does that give us the truth? If we see an anomaly, does that mean this is definitely an anomaly and there's definitely something going on that we definitely care about? Nah, maybe not. So that brings me to kind of my final point. If we look at we looked at aggregation and deaggregation and detailed data and doing a one-way ANOVA, and we looked at time series data. With the aggregation, we wound up with this little distribution of things. Well, it turns out, what are the distributions? The distributions are showing us variability. When we looked at time series, ultimately we wound up with a prediction interval. That was pretty key. That prediction interval, the key word there is interval. It was a range. We expect stuff to fall somewhere in here. So in both cases, we were actually having to work heavily with uncertainty. And that's always the case with using statistics. So this is where Matt Gershoff, my dear friend who is incredibly patient and has told me things countless times, and he tries to explain them to me so many ways. He's tried explaining to me explaining things to me sober. He's tried doing it when drunk. I think he just has to drink in order to continue to repeat the same thing to me again and again. But I woke up one morning after having been at a bar with Matt, and I said, I think I finally understood a point he's been trying to make to me for multiple years. And I sent him an email and said, am I fairly representing these 3 things about uncertainty? And he's like, yes, finally, you've got it. I'm like, okay. It really matters. It's kind of an idea, but it's really, really important. The fact is, we are operating under conditions of uncertainty. We wind up in this trap of saying, do we have significance? Because we think that significance is truth. Our stakeholders want us to give them the answer. And there is no truth. There is no answer. We always are operating under conditions of uncertainty. So great. So we just need to reduce uncertainty, right? Well, there's a cost to reducing uncertainty. I can't remember if it was in a panel or if it was just overhearing a conversation. I think it was Matt, again, shocker, said, look, if you've got some crazy deep learning thing that's a black box that gives you 90% certainty, but you could do a simple regression model that gives you 85% uncertainty that you can actually intuitively understand, is it worth all the cost of all that deep learning to just get 5% more certainty? Maybe not. Sometimes it is. But we have to recognize there's a cost in resources and processing power, sometimes in the volume of data we have to collect. And that's a balancing act we should actually be walking all the time. And then even if we said, no, I don't care about cost, I just want to eliminate uncertainty, we're never going to eliminate uncertainty. All we can do is reduce it to a certain point. And that is actually a really, really key point as well. This gets into what I call statistical thinking, one of the key tenets of it. And it's tough because our stakeholders, they don't really want to go down this path. So we as analysts have to figure out, how do we embrace this world of uncertainty and work within it and figure out how to put it to use without boring the pants or boring the pants off of, or we could bore their pants, I guess, of our stakeholders who are like, no, just give me the answer. Is it yes or no? Is it black or white? So you've officially been #Matt Gershoft. So it's going to be a thing. Search the Twitter. It's out there. So I'm actually going to do a recap in one slide. And it's actually the slide that I showed at the beginning. We talked about aggregation and hopefully got some more intuition about how deaggregating gives us a nuanced way to look at our data, and also probably tells us, like, wow, I'd much rather be working with truly detailed data. We looked at time series, which is complicated. There's kind of an expectation that we've got a stronger foundation of statistics than maybe we're going to have. But even without that, we can do things like time series decomposition and start thinking about data that we already have and have been working with for years, but thinking about it differently. And that all leads us to one of these tenets of being truly statistical thinking, which is embracing uncertainty. With that, I'm done. I have no idea if I'm wildly over or...
It's fine.
It's fine. Whatever.
Yeah.
It's 2 o'clock in the afternoon now. Okay. Thanks.